I'll record and then
Long day.
invite
Long
people.
night up ahead too. Long gonna grind. I don't know. I'll go. Zach probably doesn't want to hear that, but
Zach was telling me he was working on algo today.
Yeah,
When is
I
it due?
I actually managed to get it done in office hours. I started like on the day it came out though. So
all questions.
Next semester.
Yeah.
What
To a
do you
coding
want-
question?
you want us to
yeah, it
get
is. Oh, question 2 is
Yeah,
like
you
not
can
as
do
bad
that.
as you think.
That's your
Trust
schedule
me.
now?
It's because they give you a bunch of starter code. They're like,
Oh, really?
yeah,
Oh,
yeah.
thank you.
It's nice.
Like not
No.
having starter code
Yeah, you
is so
should push it back.
like,
and lift it
trying to
up
do that all for
with the-
yourself. Like
it's a-
Well, ironically, I didn't actually use the starter code because I code in Kotlin, but like
If I can't.
I think it should be
It's like,
pretty simple because like almost all the difficulty came from like the stuff that I didn't have in the starter code because I was using Kotlin.
Yeah.
So
yeah,
No.
3.
I did the warm-up problems today before this
Okay.
lecture.
Well, I
I
didn't
turned those
know.
in for the
this was
attendance
there
points.
when I started it.
oh nice.
So, but yeah, so if
Okay.
I can't do it here, I'm just gonna move it to spring 45.
Wars.
Mhm.
Oh, wait, yeah, wait, wars. Wait. Yeah, it's only, this is still 3.
Mhm.
Oh, shit, that's one. Who's that?
That's 10.
Yeah, wait, why is she on to you?
Because
Okay.
I made, we were planning our schedules together
Yeah. That's cute.
and I was gonna
What's that?
force her to take some classes with me.
Is that right?
This is the science of well-being. My friend took it and she loved it.
Doesn't count for anything.
You know, advisor group elective.
Advisor, aren't advisor groups electives?
Oh wait, I already have all.
Oh,
of
no,
mine.
no. Yeah,
I don't need this. That spreadsheet model. You kind of cool, right? Ames for-
Oh.
Emily took it back in the day.
Hey, yeah, I think Lauren said, I think she said it was like 3.
I don't need it now.
Those probably she could be having a good sandwich or a bunch of stuff.
I'm just like, I don't know. I'm gonna be so free next year. I can't wait.
Wait, will we be free next week or like we're just
Here.
or like why? I mean,
Okay, maybe not. Maybe looking at this, it doesn't look free, but like,
oh my god, you're gonna take 3,300. I'm gonna take 3,300.
okay, perfect.
Let's see.
Are you taking 4,300?
What's it? Oh no, I don't know.
Oh.
But that's doing too much right
Okay,
there.
I need to take a full elective. So.
Oh, Zach's in 4780 right now. I took that last
ML?
year. Yeah,
ML?
yeah.
Is it bad?
Zach likes it.
Yeah, Zach would.
I got
Yeah, I do like it. It's definitely it's hard though. Like
I got dog.
the content is hard.
Oh,
I think I'm doing all right.
Right now. It's okay.
Um,
But this is only like
why are you so cracked? Did
This
you
is-
come in
this
with
is
like
only
30,000
15 credits. I had a lot of APs. I had 3 liberal study APs, both physics, based out of multi. Oh no,
You're cool.
I know, I am.
okay. Cool.
That's so exciting.
Not pulling the transfer to you. I used to.
Okay, it's not like I tried and got rejected.
All right, there's the attendance
You
Kahoot.
didn't even try.
Uh,
That was, I missed it by like 10 days.
You know, my
that's
friend,
on me.
like, my one
Mm-hmm.
he was gonna apply to college. He just never looked to supplement. So he like did the deadline past and whatever. And then Cornell reached out to him saying, oh, you like sorry you didn't apply or something like that.
Whoa.
And then he like supplement did that day,
Mm-hmm.
submitted it, and like 2 weeks later got a
Who the fuck?
it's like,
Do we know him?
I don't know.
Yes, you did. I think I did see that. Yeah.
He's a
Okay.
businessman.
That's insane.
But
Wow. Oh wait, you know what I asked is how difficult it is? I don't think we have the premium version of Kahoot. Oh, we should have. Oh, extra credit if you guys show up in your costumes next week. Well, I'm saying it. If you dress up and you come and your costume is fire, we'll give you a couple extra points.
Fire is very subjective.
I know, it has to be fire to us. We have 2
yeah,
volunteers.
we'll be the judges.
Okay.
Oh, wait, am I sharing my screen? I don't think I'm sharing my screen. Yeah. Okay.
Get out. Like, difficulty rating? That's like 5 or something.
Yeah. I mean, I do think it is kind of a difficult class, honestly. Like,
I agree.
yeah. Oh, wait. Oh, did I accidentally remove one of you? Okay, one of you may need to rejoin. Yeah, make sure everyone joins. We'll give like a couple more minutes and we'll get started.
It is getting so cold.
Yeah. It's actually supposed to be a bit warmer this week though. So,
I'm excited.
but I think I'm sure next week it's gonna be like freezing.
Yeah, it's like karma.
Yeah. I think we're still missing a few people.
Who still needs to get in? Okay, no rush. Wait, that's me.
Let's see.
I mean, don't go to my
5,
stall
9.
that ID and join the game. But
Okay.
Daniel.
I think, all right. Is anyone still not in? Otherwise, we will start. Raise your hand. It's fine if you're not, but we want to know. Yeah. Okay. We're gonna get started. Tried to put in some tricky questions in here. What is an intent? Choose the best answer.
Wow. I better win.
Yeah, so if you've learned anything from multiple choice tests, you know, the longest answer is usually the best answer, and that happens to be true here. So, basically in actions that have both implicit and explicit versions, right? That's technically true, but that doesn't really describe the nature of intents. So intents are a messaging object that we use to request an action from another app, right? So that's a much more like informative definition that tells exactly like what an intent is. So I definitely think that's the best answer there. Just saying that it has implicit and explicit versions, while that may not be true. I mean, while that may be true, it's not really like a very descriptive answer. So, yeah. All right, let's go next. Interesting question. So it's the types of the parameters. And just try to see if you can figure this one out. I know I like to make my questions tricky. Okay.
Oh.
Wow, no one got this right. Okay. So let me explain this one. This is why I like to make my questions tricky, so everyone learns something when I make the code, right? Okay, so essentially the reason that it is, let's talk about first the most popular answer, right? This and class.java. So basically the idea behind this one is you probably saw the syntax that we use to essentially create the parameters for our intent constructor, right? And the first thing that we always pass in is this. But the thing is that I asked, what are the types of the parameters? So this is actually, it's not a type. This is a keyword in Kotlin that we use to specify like our current class, right? So you can actually immediately eliminate this answer because this is not a type and we're looking for the types of the parameters. So, and this class::class.java, right? Again, even though that's the syntax that we use, class::class.java is not actually a type. So if you remember, I think I like did a little interjection when Sophie was lecturing last time, and I gave you a brief introduction to context. And that is actually what you pass in. So first, your intent needs context. Like essentially it's where you're going from. And then your class is where like essentially where you want to go to, like what app you want to open, right? And these are both Kotlin types. So yeah, this is the correct answer. In terms of action type, action receiver, I mean like you sort of have the right idea, but that's like not really what we're looking for here. We're looking for the actual types in Kotlin. So yeah, hope everyone learned something from that.
But I'm glad you all remember what to like put into those little parentheses.
Yes, it's good that a lot of people remember the syntax. Not really much of a change to the leaderboard there. Okay. So this we haven't really gotten to yet, but it's foreshadowing for today's lecture. Right. So here, I'll admit I probably should have put choose the best answer because I'd actually say there are multiple correct answers here. Like infinite scroll, like sure you can think of it as an infinite scroll, right? You're just scrolling through like an infinite feed of posts. Like a complex app component, that's not really that descriptive. A gallery view, we're more so talking about like general app development concepts, right? A gallery view isn't really something that I would call like an infinite scrollable list. So I can definitely see why a lot of people said infinite scroll. I would say that that is like a valid answer. But in my opinion, the best answer here is lazy list. And we're going to get into like, what does that mean? Why is the list lazy? You know, why is it like waking up late on a Monday morning or something, right? We'll get into why we have a lazy list in soon. But yeah, so just keep that in your mind. And we'll continue. Okay. Are you excited for today's lecture?
Wow. You should have put a note in there.
Awesome. Looks like everyone's excited for today's lecture. So happy to see that. The reason you should be excited is because we're going to learn the technology essentially that's behind Instagram's feed. We're going to learn how we can create these nearly infinite lists and have it not only like be nice and aesthetic, but also perform really well. So yeah, that's today's lecture. That's why you should be excited and why you all are excited according to the poll results. So yeah, congratulations to the winners. If your net idea is up there, be proud. Nice job.
Someone still signed it as me.
Cool. Okay. Let's get into the presentation for today. You forgot to stop the music. Oh wait. Yeah, okay, everything's recorded, so it's fine. Okay. Cool. Yes. All right. Lecture 4. First, we want to know how is homework 2 and how is like homework 3 coming along? Anyone want to share? How about who has started homework 3? Raise your hand. Okay, great. Yeah, it's due tonight.
So
So
thank God. Woo!
most of us have started. That's really good. If you haven't started, that would be not so good. So yeah, good job starting that. Is who has submitted homework 3?
Let's go.
Okay. Got a couple of hands there. Nice. Cool. Okay. Any questions about these assignments? Like brief questions. This isn't office hours, but like logistical questions.
What would you guys say like the hardest part of doing these assignments is? Like just
That's a good question.
learning stuff or like syntax or like getting help? Yeah.
Like finding like all the questions to actually like do the things like searching up what questions has the HSP.
The documentation part, like going online, finding stuff. Yeah, that's valid.
Figuring out how to actually use the permissions has been really hard. Like use the thing that you got the permissions for.
Got it.
Yeah, permissions is pretty complex. There's like different like callbacks and stuff like that, and you kind of have to it like requires like a bit of knowledge like on these types of libraries in general, right? So like I think interfacing that for the first time would definitely be challenging, but I mean these assignments like should challenge you and you should like ultimately walk out like a better developer than you were before after each assignment. That's what we hope. So
Don't worry, this was my least favorite assignment when I took the class. But homework 4 was my favorite assignment. So you guys should get ready. to be
yes.
excited.
Okay. Let's get started with recycler views. That is the name of the essentially the way that we implement a lazy list in Android native. So we'll get into that, what all of that means and stuff like that. So yeah, let's talk about infinite lists, right? They basically power like almost every app you use. It's such an essential concept. So here, this is like, is that like Facebook probably? Or yes, that's Facebook. Great. Facebook uses an infinite feed. Spotify, right? All your songs. Amazon to show all these products, right? So if we didn't have these performant infinite lists, like we wouldn't have a lot of the apps that we have today, or they'd run like super slow, right? So how do we actually go about implementing a list like this? So that's what we're going to talk about. The first, like, we have to consider some things when we're implementing a list like this. So a long list of data would be super slow if all the items are loaded at the same time, right? So imagine I'm on Spotify and I have like a playlist of 136 songs, and I try to render each of those song items at the same time. That would cause lag for the user, and that would be like a really bad user experience, right? So we shouldn't load all the items at the same time. We should only load the items that are actually on the user's screen. And the other like important consideration is that items need to respond when we update the data inside of them, right? So we need to make our list not only like performant, but also responsive. So we're going to talk about how to do that. And yeah, the solution is a recycler view. So a lazy list is like more of an umbrella term, and recycler view is like a specific implementation of a lazy list. So a lazy list is essentially a list for which each item is rendered lazily, right? So what that means is that this like list item, it's not going to be eager, and it's not going to like immediately render, right? It's going to wait. It's going to just be lazy and chill until our user scrolls into it, right? And then it's going to render. So it's kind of like it's being lazy. It's like procrastinating the rendering until the user like actually sees that element. Okay. So that's like a really important consideration. And this is what allows our list to be performant. So we only want to render elements when they are like about to come into the screen. And that's how we're going to create a nice like smooth experience for the user. The other important thing is that views are recycled. So let's say I start at the top of a 1000 element list and I scroll all the way to the bottom, right? A potential issue could be that if I scroll all the way to the bottom of this list and I'm still rendering like the first list element, the second list element, all the way up to the 1000th list element, right? Then that wouldn't have really solved my problem using lazy rendering, because I would still be rendering 1000 list items at once, which is really bad, right? So the way that recycler view solves this problem is that when views are scrolled off the screen, they are recycled. And then these views are actually reused when we scroll new items into views. So we have a nice visual for that coming up, but essentially a recycler view addresses like our prior concerns. Anyone have any questions about like what any of this means so far? Okay. Cool. So here's that visual I was talking about earlier, right? So if the user is scrolling vertically, we have the views that are visible on the screen, and we have the views that are not visible. So these views that aren't visible will essentially be scrapped, and it's going to go into this recycled state, right? And think about the XML layouts in Android Studio. So remember how when we write XML, we get a live preview of what's going on, right? And that just shows how performant XML is. So the idea is, what if instead of like when we scroll, right? Instead of completely getting rid of this view, we put it in a recycled state where we have our XML layout rendered, but none of the fields are actually filled in with the values that we want, right? So the idea is that this like eatery car, or that's not eatery, that's that is the Edinburgh station. So this like geography card has an image and a text, and all geography cards will have an image and a text. So we keep this image and text, like the general structure of the view rendered. And then when we recycle and reuse that structure, we then bind the new data to the new card. Okay. So raise your hand if you're with me. Does that make sense? Okay, cool. Yeah. So yeah, that's basically that. That's like a high level overview of what a recycler view does. Okay. Yeah, so now let's talk about like the implementation details. So this sounds really great on paper. It sounds like we have this amazing solution, and we do. But the thing is that Recycler View and Android Native has a lot of boilerplate code. And if you haven't heard of that term before, it's essentially just means that like code that we kind of have to fill in for like syntax reasons that we might not really need, right? So I'll talk about that right now. So the first like essential part of a recycler view is data. So if I go back to this like example of these like geography cards, I'll keep calling them. Their main data here is an image and a location name. And we could represent this as an object in Kotlin, right? So in Kotlin, when we have these representations, we use data classes. And I just did like a really basic example for like a color and a value. So maybe I want to like correspond red, like the string red, with the value that would be like its hexadecimal format, right? And this is a data class representation of that. And yeah, then we have a layout. So this is a basic example of what like an XML layout for a recycler view item might look like. So remember, we want to be able to reuse this layout, right? So this layout should be generalized, and we should be able to like continuously repopulate the fields each time that we have these layouts like coming into view. So this will be replicated for as many pieces of data that you have. Yeah, that's a little bit about the layout. So this is actually going to be an XML file in your Android Studio code. So yeah. The next thing is a layout manager. So we tell our recycler view, we give it all the data, and we give it like the adapter, which we're going to get to a little bit later. But the thing is that the recycler view might still not know how to position the items, right? So should we have like a side scrolling list? Should we have a vertical scrolling list? Should we have a grid like you might see on Instagram, right? So these layout managers allow us to tell the recycler view what way we should organize these items. Okay. The next part is the adapter. So I like mentioned this a little bit, but essentially the adapter is able to take our data class representation. So back here, right, we have our data class of a color and a value. And let's say that we wanted to display the name. Our goal is to display the name of the color and like a box that has the color in it, right? So how would our adapter work in this scenario? Essentially, we would have each item, which is an instance of the color value data class. And our adapter would tell the recycler view how to handle each field in our data class. That's essentially what it's doing. So it'd say, okay, let's make the text equal to the color name. And let's make the box have the same color as the color value, right? So that's what our adapter is going to be doing, processing each item. And then from there, once it's been adapted into these XML layouts, that's going to populate our screen. Yeah, I think that's the adapter. Yeah, and then the view holder. So the view holder is like an instance of your XML layout. So the difference between like a view holder and just the layout of an item, the layout is more so the XML code, but the view holder is a live instance of your XML code that's in the recycler view. And we want to essentially, our goal is to bind data to this view holder through the adapter. Yeah, and we also see that view holder should extend recycler view.viewholder, which basically just means that like recycler view.viewholder is a class that Android gives us that tells us what the essential properties of a view holder are. And by having view holder extend this class, we ensure that our view holders have all the essential properties that view holders need in Android. Yeah, okay. So now we're going to get into a bit of the implementation details. And this is going to seem complicated, and like you definitely don't need to worry about like what all this is doing. So this is some of the boilerplate that I mentioned earlier. So this on create view holder, this implementation is going to be like almost the same every time, because all you're doing is you're just creating a new view holder with no associated content, right? So you're essentially just initializing an instance of your XML layout, and you're preparing that item to be bound to data. So that's what this method is doing. yeah, it's the syntax is definitely weird, but it's essentially like the main point is this r.layout.book row item, right? So in this case, I guess they have some sort of application that has to do with books, but basically this is the key thing that you're going to change because this references where the layout is in your XML. Okay, so yeah, if you don't understand this, like I don't completely understand it either. It's just a lot of boilerplate syntax that you need. But yeah. Another method of the adapter is on bind view holders. So this one's a bit more intuitive, I would say. It's less boilerplate. So we essentially associate our view holder with data. So remember, a view holder is an instance of our XML layout. And we essentially take the items in our XML layout and we set them up with the actual data that we want to bind, right? So in this case, we set the text to the book name. We set the author to the author name of the data, right? And this position tells you which index in the list that your view holder is at. So like each view holder in your recycler view is going to be at an index in the recycler view. This position tells you which index the view holder is at. And it would make sense that in our list of data, we want to display the data that's in the same position that our view holder is at. So I think that should make sense. Does anyone have like any questions about this code?
I just want to say like this position field is very important because like say you want to make a change to your data set, which you guys will be doing in your next project, you're going to want to use that position variable to kind of like tell you where you are in your list and where you are in your data set so that you can make some changes. So just make sure like you totally get this part because all you're doing is taking that view holder that's like at position 5 and you're putting in the data that's at position 5 in your data set. So you're just swapping it out.
Right. Yeah. And to add on to that a bit, like I think what's really important is that like as I've been emphasizing, we want our recycler views to perform really well. And the way that they do that is like we wanted it to be responsive, right? So the question arises of like how are we going to update data because we don't want to go through all like 1,000 or so items in our list and check if the recycler view needs to be updated for those positions, right? And like it's just like another way of stating like the motivation behind like why we need to tell the recycler view that the data is changed at a certain position and instead of just be able to say, oh, your data set changed. The reason is that we don't want to have to re-render everything. We want to only have to re-render the thing that we know that changed. And we can do that with positions. So, okay. Yeah, then the last one, this is like the easiest function ever, basically. Get item count. It returns the size of your data set. It's going to be like almost the same pretty much every time. It's pretty rare that you see an implementation that is not like this. So yeah, essentially, this is actually a really important method though, because if you get it wrong, your recycler view will be returning will be showing, but it might not show all the data in your set. So if I had a data set of size 10 and I set this get item count to 5, it would only show 5 view holders, right? So yeah, this is really basic, but also really important that you want it to be based on your data set's size. Yeah. Cool. Okay, so now I'm going to show you another implementation of like of this idea of a list. And this one is called a list view. So it's a lot simpler, but it's far less efficient. So a lot of the benefits that I was talking about and why recycler views are like so amazing, list views don't have. But what they do have is a much simpler implementation and a lot less boilerplate. And I'll go over like a practical example of when you would use this, but just make sure that you're like in app development, you almost always want to use recycler view, but there are some rare cases where list view is applicable. So I'll be going over that now. So yeah, a use case for this might be a finite small number of data items. So for example, let's say that you have a settings page in an app. So this app is actually called Read It. This is an app that I made for a competition in high school. Yeah, it was pretty fun. It's basically like Reddit for academics. But here you can see that we had a settings page for the user and we had all of these different items, right? And like you can see that each item is a very simple display. It's just an icon and text, right? And we want to keep repeating this display, but we don't want to copy and paste XML code. So we just use list view. And the other key reason we use a list view here is that there's never going to be a situation where all of these items are not being rendered at once, right? So I think that's a really key distinction. You actually don't want to overuse recycler view. Like I see in mobile development, like I've like reviewed other people's code in like various projects I've worked on, and some people will unnecessarily use like more complicated versions of views when they don't need to. So the key distinction about like when you're choosing to use a list view versus a recycler view, you need to ask yourself the question, is all of the views going to be on my screen at once? So if the answer to that question is always yes, then you can just use like a basic list view because it'll have like the same performance as using a recycler view. But if the answer is no, and the user is going to have to scroll through this data, and it's not going to be all on the screen at once, right? Then you'd want to use a recycler view. Yes. Okay. Cool. Yeah. So let's talk about the list view implementation. So this is like, you can see that it's actually really basic. So all we're doing is we have our list items and we have a list adapter, and the list view has adapters predefined for us. So for a recycler view, we create the adapter from scratch every time. But for a list view, they already have it built for us. So it makes it like really simple, right? So we can just say, oh, we want an array adapter. We want it to adapt an array of elements. And then we can even specify the XML layout. So simple list item 1 is actually a built-in layout for list items. So we don't have to define our own custom XML, right? And yeah, and then menu list, that's just the array that we're actually passing into our adapter. Yeah, so you can see like some notes here. Yeah, okay. But like as we said, even though this list view implementation is super convenient, right? Instead of having like a whole separate class for your adapter, you just have it basically like a few lines of code, right? So it's really convenient, but you want to make sure that you consider the drawbacks of a list view. So it only supports vertical scrolling, it has a slow performance for large lists, and it creates as many views as the number of elements in the list. So again, when all your views have to be displayed on the screen at once, like no matter what, then using list view is fine. But in any other scenario, you should really be using a recycler view. So cool. Okay, so now we're going to talk about the Jetpack Compose version of this, which is lazy lists. So we've been like sprinkling in Jetpack Compose throughout the lectures, but just as a brief reminder, it's the more like modern UI framework for Android that you're probably going to be encountering later on if you do stick with Android development. So I think it's good to get exposure to this. And I think you're going to like what you'll see. So first, there's different types of lazy lists. So you have a lazy row, a lazy column, lazy vertical grid, and lazy horizontal grid. And like the great thing about Compose is that these are all really intuitive. Like just by looking at the name lazy row, you can say like, okay, it's a row of content that I'm going to scroll through, right? Lazy column, I'm scrolling through a column of content. So these are all like super intuitive and just easy to use. And the other great thing is the syntax is actually super simple. So we have our lazy column, and we essentially just specify the items in the column, and then these texts, these are composables. So yeah, and the great thing about this implementation is you can replace lazy column with any other lazy list type and it will just work. So yeah, modern Android development is really great. I think it's good to get exposure to it, but for this course, it's also good to see like the lower level details of Android development, which is why we're doing native. But cool. Okay, so now what perhaps you've all been waiting for, a demo of how we actually implement a recycler view. So I may have like only shown a few of the functions in the guide, but we're gonna show a full implementation like from the start. So yeah, if you want to follow along, please do so. We're gonna do an empty views activity. So yeah, and let's see, we only have like 20 minutes left, right?
Mm.
So okay. I'm trying to see how I can pace. I think I'll try to go relatively slowly. Hopefully everyone can follow along. So make a new empty views activity and make sure you choose this one, empty views, otherwise it won't work. Yeah. Okay. So sure demo. And here we are. Cool. Okay. So I think the first and like the easiest thing to do, right? Like when you're developing, you always just want to do the easiest thing first because it's the easiest. So let's just get the easy stuff out of the way. And what we're gonna do is we're going to set up our XML. Okay, so as I said, I prefer to do this like in the code view. You can also do it in the design view if you want to, but essentially we're going to be starting off by getting rid of this text view, and we're going to put in our recycler view, and we're going to have the width and height be wrap content. So we only want the recycler view to be as big as its list elements. And then we have to add our constraints. So this actually tends to be faster in the design window. I like to have both up, so you can just drag them to the sides and just make it like nice and centered. So there we go. Okay, cool. So our XML for our main activity should be done. Okay, so raise your hand if you have your main activity XML in. Okay. Seems like we have a decent amount of people. I'll give a little bit more time just to create the project. I know Android Studio can take a bit to load for some of you, so yeah, I'll give you a bit of time here. But essentially, yeah, we just made the XML wrap con. Not really too much to explain here. So okay. So hopefully that was enough time for you to catch up. I do want to get moving though, because we have about like 20 minutes. So just want to make sure we get everything in. Okay. So implementing a recycler view from scratch like is kind of a lot of work because you have to, like, we're not even done the XML part yet. We still have to make our item view. So the way that we do this is we go into layout, and I want you to right click, new, layout resource file. And this is going to allow us to just add another XML layout to our code. So I'm going to call this recycler item. So this is just an item that we're going to put into our recycler view. And I'm going to go back to the code here. And essentially what we want to do is we want to make this item, instead of a constraint layout, we're actually going to use something a bit different. Like you'll see in modern designs that they have card views, right? They're basically just white boxes with like shadows, right? So we're going to use Android's implementation of that. So if you want to do this with the code, I think it's a lot easier to do this with the code editor actually. So if you highlight, if you highlight this constraint layout and you start typing card view and press tab. So now our layout is a card view. And what we're going to do is add a shadow to that, so it has a nice presentation. Shadow in Android is called elevation. So we're going to do 10 dp. And make sure you're using the autofill as you type because it makes things a lot faster and easier. And the other thing we're going to do is we're going to change these widths and height to wrap content. So the card will only be as big as what's inside of it. And then we want to use compat padding, which is just a weird styling thing, but basically it makes it so the shadow doesn't get cut off. Yeah. And then we want to add some text. So for now, I'm not going to make a custom data class since we're going to do that in the demo next class. But we're going to make a text view, and essentially we're going to just add some text to it. So user one, it's just this is going to display like a list of the Android subteam members. So very fun. Yes. So we're going to extract this resource. Again, this is just best practice. Like you'll see a little highlight when you type directly into the text, and you should extract it. And I personally prefer just having the black text color. I'm going to make the size a bit more readable, 40. And we're also going to make the width a bit bigger. So we're going to say 400. So it like fills up most of the screen. Okay, cool. So that should be good for our for our layout, just to like review what I was talking about in the slides. So if I have like a live instance of this layout in my recycler view, what do we refer to that as? Does anyone remember? I said it a good amount during the lecture. Let's see. Anyone? Okay. Well, I guess we'll see actually during the code. So you'll see why like knowing that is useful as we're writing the code. So yeah, I'll come back to that. Okay, cool. So we have our XML in, that's the easy part out of the way. And we're going to continue doing the easy parts. So we're going to go to our main activity and we're just, oh wait, actually that reminds me, I forgot to add IDs. I always forget to add IDs, but it's fine because you can add them in later. So add an ID to your recycler view. I'm going to call mine my recycler. And then you should also add an ID to your text in your recycler item. So I'm going to call this username text. Okay. So yeah, having IDs is important because we need to access them from the code, right? So let's go back and now let's start accessing our views. So this is the easy part. We know how to do this, right? This is just find view by ID, r.id, my recycler. And our data is, we'll do this. So it's going to be an array list. And actually, I'm just going to copy and paste it from, like the demo that I made before this lecture. So, yeah, you don't have to do the Android subteam members. You can do something else that you want to do if you want to. But, wait, did I miss anyone in here? That'd be funny if I did. Okay.
Hope not.
Yeah, so we're gonna repeat. Okay, so just to show, I want to show the power of the recycler view. So I want to make a really big list. So I'm gonna do repeat 10, and repeat is actually kind of a cool Kotlin function. And it basically just like runs the code inside of it however many times you put here. It's like it's a shorthand for a for loop. So yeah. Data dot add all data. So I'm going to basically add data to itself 10 times, and that's going to make this list like really huge. Just so we get it nice and big. Then we're going to get, actually we're not there yet. So cool. Okay, so we have our data and our recycler view, and now what we need to do is create the adapter. So this is like tends to be the more tricky part of creating a recycler view. So does anyone want to refresh me on what is the job of the adapter in our recycler view? I'll wait this time. I don't want 2 questions to go by with no one answering. And you can just take a guess if you don't. It's fine if you're wrong. I just want to see. So what do we think, like you can give like a high level overview, right? What do we think the purpose of having an adapter is for our data? Right? We need to get our data into the recycler view. So yeah, exactly. So we have our recycler item, right? And we have this specific format of our user, and we have this list of users, and we need to adapt this list of users to each recycler item layout, right? And we need to essentially put each string, and we need to specify each string should be in this user text. So the purpose of our adapter is to essentially bind like each of our data elements to the recycler view. Okay, cool. So yeah, we'll continue that. So we're going to make our adapter now. So I want you to do new Kotlin class / file, and we're going to call this my recycler adapter. So we're creating a custom recycler adapter class. Okay, so the syntax definitely gets a bit funky here. The first thing that we're going to do is put parentheses after this class, and we're going to do this. We're going to say private val dataset, which is of type list of string. So if you've seen in Java, when you have your class and you have your constructor, right, that basically says like when we instantiate an instance of this class, what are we going to pass into it? We're going to pass in like the methods of the constructor. So this is essentially Kotlin's like shorthand for creating a constructor for this class. So whenever we instantiate an instance of myRecyclerViewAdapter, we need to pass in the data set that we're going to be adapting. So this should make some sense, I would say. And then before, so our next step is going to be create the viewHolder class. So, this viewHolder class is going to take in an item view into its constructor, and it's going to extend recyclerView.viewHolder of item view. Yep. Okay. Cool. So essentially, what this is doing is we're defining our viewHolder class. So again, like related to that question that no one could answer before. It's a huge hint, right? Does anyone remember what a viewHolder is? Let's see. It's very heavily related to the question that no one could answer before. So last time I asked, what is a live instance of our XML layout? No one can answer that question. Now I'm asking, what is a viewHolder, right? So a viewHolder is a live instance of our XML layout, okay? So basically what this viewHolder class does is when we instantiate this viewHolder class, right? It's basically going to act as a code representation of our list item, okay? So, and the only way that we can get this code representation is if we pass in an item view into the viewHolder, and we can actually get things out of that item view. So you'll see what I mean in a second. So we're going to say that our username text is of type text view. And then whenever we initialize this class, right, we want to set the username text to to item view dot find view by ID r.id dot username text. So what that's going to do is whenever we instantiate a live instance of our layout, right, we're going to have access to this username text. And yeah, when this initializes, we're going to be able to access this in the username text variable. And now we need to do another thing to our class. So we're going to go back up to our class, and we're going to say that this class extends recyclerView.adapter of myRecyclerAdapter.viewHolder. Okay, so we do have some errors, and the reason is that we have to change this to put parentheses after it. So this is what I was talking about with boilerplate, right? There's a lot of weird syntax, but conceptually what this is doing is we're essentially asserting to Android Studio, we're saying that our recycler view adapter has all the properties of a recycler view adapter by the way that Android Studio defines it, okay? And to make that assertion true, we have to implement the functions that Android Studio requires us to. So we're gonna hover over this error, click on implement members, and then hit OK. And that's going to give us a really nice template for all the functions that we need to fill out. So we went over each of these in the slides. So on create viewHolder, right? This is what happens when we create an instance of our viewHolder. So yeah, if you want to know the specific syntax for this, I'm going to just type it up, val view equals layout inflator dot from parent dot context. So again, we're using context here, which is interesting. We're going to inflate. And what layout are we going to inflate? We're going to inflate the recycler item because that's what we want to put our data in. And we're going to do parent and then false. So yeah, a lot of weird syntax. Don't worry about the specifics of what this means. As long as you can just copy this down, it's fine because it's going to be pretty much the same every time you implement recycler view. Then get item count. So remember, that's the easiest method in our recycler adapter. So what do we think this should return? Exactly, yeah. So dataset.size. And you can see that I actually did this shorthand equals dataset.size. You might have thought of doing something like this. Return dataset.size. And that's completely fine as well. Either way that you want to do it is totally fine. But I'm going to use this shorthand. So we're just saying that whenever this function is called, we're just going to return the value after the equal sign. So yeah. And then our last thing that we need to do is on bind view holder. So this is when we have our view holder and we have the position and we need to actually populate the data of the view holder. So the way that we're going to do that is with holder dot, and we want to get our text view. So username text dot text is equal to data set of position. So we're just getting the Android subteam member that's at that position, and then we're binding that subteam member to the username text. Okay, great. So that's it for our adapter. So again, it's a lot of complicated syntax, but you can see that the implementation itself is actually not that long. So yeah, pretty good. Okay. Does anyone have like any questions about any of the code here? Or like, yeah. Yeah. So to like remind you of what position is, it's essentially we have, whenever we're scrolling through our list, right, there's going to be items like at the top and there's going to be items below that, right? So the item at the top of the list in our recycler view will always have position 0, and then items below that will have like position 1, 2, 3, etc. So it shows where on our recycler view that that data set there, that data object is, right? And we want to populate that data object based on where it is in the recycler view, right? So suppose we didn't know where the data was in the recycler view, and we just got some random view holder, right? Then how do we know what to put in that view holder? Like, we don't know if it's the first element, we don't know if it's the second element. So that's why we need that position. So just to really make sure. Does that make sense? Okay, great. Okay. Cool. So we're gonna go back to our main activity, and there's only a couple steps left. So we're almost there. The first step is we need to make an adapter value to store our adapter class. So we want an instance of our adapter class. And remember, our adapter class, we gave it that constructor that to have an adapter, we need a data set. So we're going to pass in our data. And then what we're going to do is set the recycler's adapter to the adapter that we just made. And then the other thing that a recycler needs that is like actually pretty easy to forget, I've forgotten this a few times when implementing recycler view, is the layout manager. So layout manager, and we're gonna say that it's just a linear layout manager, which just means that the items are going to be organized vertically. So yeah, and then we need to pass in context. So since we're in the main activity, we can just use this for our context. Okay, so that should be the implementation finished. There's one other thing, or actually, we'll just try running it. We'll see what happens. But and I think yes, we're gonna get a crash here. That's just, again, my computer is weird. It like doesn't automatically set the right version of Android. If you're getting an error that says update your project, then all you have to do is update your project. So that's going to be in the build, in like the app level build.gradle file. That's what that's called. It has this little app next to it. And we're going to upgrade this to 34. We're also going to upgrade this to 34 and just sync it. So now we're going to rerun the app and we should have a nice working recycler view. Let's see what happens. Okay, here we are. So there's the entire Android subteam. It would be great if we had this many members. We'd be very productive. But yeah. So as you can see, right, this list is insanely long. It would be a pretty fun combinatorics problem if you want to try to calculate the size of this, or like come up with a formula for the size of this. But yeah. So basically, this is a really, really long list. I don't know how long it is, but you can see we can scroll so fast and we're not losing any frames, right? You can just keep scrolling like forever. It's really cool. So yeah, that's your implementation of the recycler view. Anyone have like any questions about anything at all? Yes. Yeah, sure. And that brings us exactly to 9:25. Very good timing. So
Yay.
yeah, if anyone still has any questions, come to me afterwards. Let me know. Otherwise, you're free to go. So thanks for coming, everyone. Yes.
Give the motion.
Uh,